Electrical wiring safety is critical for preventing fires and electrical shocks. While it's impossible to assess the safety of specific wiring without a visual inspection, several general guidelines should always be followed. Firstly, always use the proper gauge wire for the amperage that will be drawn through it. Wire gauge refers to the physical size of the wire, typically measured using the American wire gauge, or AUG, standard. The smaller the AWG number, the larger the wire diameter and the more current it can safely carry. Selecting the correct wire gauge is crucial because undersized wires can overheat, melt insulation, and potentially cause a fire. The National Electrical Code, or NEC, provides tables that specify the allowable ampacities for different wire gauges and insulation types. These tables take into account factors such as the ambient temperature and the number of current-carrying conductors in a raceway or cable. For example, NEC Table 310.15b16 provides ampacity ratings for conductors insulated with common materials like THHN, THHW, and XHHW. When selecting a wire gauge, you must consider the maximum current that the circuit will carry. This includes the amperage ratings of all appliances, lights, and other devices that will be connected to the circuit. It is also important to factor in any potential future loads that may be added to the circuit. To determine the appropriate wire gauge, calculate the total load on the circuit and then consult the NEC tables to find a wire gauge that has an ampacity rating equal to or greater than the calculated load. For instance, a 15 amp circuit typically requires a 14 gauge wire, while a 20 amp circuit usually requires a 12 gauge wire. However, these are just general guidelines, and the specific wire gauge may need to be larger depending on the installation conditions and the type of insulation used. Secondly, make sure that all connections are tight and secure. Loose electrical connections are a common cause of electrical problems and can create a fire hazard. When electrical connections are loose, they can create resistance to the flow of current. This resistance generates heat, which can cause the wires to overheat, melt insulation, and potentially start a fire. Loose connections can also cause arcing, which is a phenomenon where electricity jumps across a gap in the connection. Arcing creates intense heat and can also ignite nearby flammable materials. To ensure that all connections are tight and secure, use the proper tools and techniques. When connecting wires using wire connectors, such as wire nuts, make sure to twist the wires together tightly before applying the connector. Use a wire nut twisting tool to ensure a secure and consistent connection. When connecting wires to terminals on devices such as switches, receptacles, and circuit breakers, tighten the terminal screws to the proper torque specification. Using a torque screwdriver or wrench can help ensure that the screws are tightened to the correct level. Periodically inspect electrical connections to ensure that they remain tight and secure. Over time, connections can loosen due to vibration, temperature changes, or other factors. If you find any loose connections, tighten them immediately. Thirdly, avoid overloading circuits. Overloading a circuit occurs when the total amperage of all devices connected to the circuit exceeds the circuit's rated amperage. This can cause the circuit breaker to trip, which is a safety mechanism designed to prevent overheating and fires. However, if the circuit breaker fails to trip, the wires can overheat and potentially start a fire. To avoid overloading circuits, calculate the total load on each circuit and make sure that it does not exceed the circuit's rated amperage. The rated amperage of a circuit is typically indicated on the circuit breaker. For example, a 15 amp circuit is designed to handle a maximum of 15 amps of current. When calculating the total load on a circuit, consider the amperage ratings of all appliances, lights, and other devices that will be connected to the circuit. The amperage rating of a device is usually indicated on a label on the device itself. If the label only indicates the wattage, you can calculate the amperage by dividing the wattage by the voltage of the circuit. For example, a 120 volt appliance that consumes 600 watts of power will draw 5 amps of current. Calculated as 600 watts divided by 120 volts equals 5 amps. Avoid using extension cords or power strips to connect multiple devices to a single outlet. Extension cords and power strips can easily overload a circuit, especially if they are not rated for the amperage of the devices connected to them. If you need to connect multiple devices to a single outlet, consider installing additional outlets or a multi-outlet power strip with a built-in circuit breaker. Fourthly, do not run wires through walls or ceilings without first checking for studs or joists. When running electrical wires through walls or ceilings, it is important to protect the wires from damage. Wires that are run through walls or ceilings can be easily damaged by nails, screws, or other objects. Damaged wires can create a fire hazard or cause electrical shocks. To protect wires that are run through walls or ceilings, use conduit or cable protectors. Conduit is a rigid metal or plastic tubing that is used to enclose and protect electrical wires. Cable protectors are plastic or metal devices that are used to protect cables from damage. When running wires through studs or joists, make sure to drill holes that are large enough to accommodate the wires without pinching or damaging them. Use a drill bit that is slightly larger than the diameter of the wire or conduit. Also, be sure to maintain a safe distance from any existing wiring or plumbing. Before drilling any holes, use a stud finder to locate the studs or joists in the wall or ceiling. This will help you avoid drilling into existing wiring or plumbing. Fifthly, if you are not sure how to do something, consult with a qualified electrician. Electrical work can be dangerous, and it is important to take precautions to protect yourself from electrical shock and fire. If you are not comfortable working with electricity, or if you are not sure how to do something, consult with a qualified electrician. A qualified electrician has the knowledge and experience to perform electrical work safely and correctly. They can also help you troubleshoot electrical problems and ensure that your electrical system is up to code. When hiring an electrician, make sure to check their credentials and references. Ask for proof of insurance and licensing. Get a written estimate before the work begins. Some additional tips include always turn off the power before working on any electrical circuit. This is the most important safety precaution you can take. Use a non-contact voltage tester to verify that the power is off before touching any wires or terminals. Wear safety glasses and gloves when working with electricity. Safety glasses will protect your eyes from sparks and debris, and gloves will protect you from electrical shock. Never work on electrical systems in wet or damp conditions. Water is a good conductor of electricity, and working in wet or damp conditions can increase your risk of electrical shock. Inspect electrical cords and appliances regularly for damage. Damaged cords and appliances can create a fire hazard or cause electrical shocks. Replace any damaged cords or appliances immediately. Install ground fault circuit interrupters, or GFCIs, in areas where water is present, such as bathrooms, kitchens, and outdoor areas. GFCIs are designed to protect people from electrical shock by quickly shutting off the power to a circuit if a ground fault is detected. Install arc fault circuit interrupters, or SIs, in bedrooms and other areas where there is a risk of arcing. SIs are designed to protect against fires caused by arcing. Keep electrical panels clear of obstructions. Electrical panels should be easily accessible in case of an emergency. Do not block access to the panel with furniture, boxes, or other items. Be aware of the signs of electrical problems, such as flickering lights, tripped circuit breakers, or burning smells. If you notice any of these signs, investigate the problem immediately. If you are not sure what is causing the problem, consult with a qualified electrician. By following these safety guidelines, you can help ensure that your electrical system is safe and reliable. Remember, electrical safety is not something to be taken lightly. If you are not sure how to do something, always consult with a qualified electrician. Regular inspection of your electrical system is a good practice. Check for any signs of wear and tear, such as frayed wires, cracked insulation, or loose connections. Pay attention to unusual smells or noises coming from electrical outlets or appliances. If you detect anything suspicious, turn off the power to the affected circuit and contact a qualified electrician. Consider investing in a surge protector to protect your electronic devices from power surges. Power surges can damage sensitive electronic equipment such as computers, televisions, and stereos. A surge protector will help to absorb excess voltage and protect your devices from damage. Educate your family members about electrical safety. Make sure everyone in your household knows how to use electrical appliances safely and what to do in case of an electrical emergency. Post emergency contact information near the electrical panel. This will make it easy to contact a qualified electrician or the fire department in case of an emergency. Stay informed about electrical safety codes and regulations. The NEC is updated every 3 years, so it is important to stay up to date on the latest changes. You can find information about the NEC on the National Fire Protection Association or NFPA website. Remember, electrical safety is an ongoing process. By following these tips and staying informed, you can help to keep your home and family safe from electrical hazards. If unsure, always consult a qualified and licensed electrician. They can assess any issues and provide solutions to keep the electrical system working safely.